All right, here we're going to find the perpendicular bisector of a line segment. And we have a little bit of an added difficulty thrown in. Just to illustrate or remind you of how we worked before to find perpendicular bisectors. If I had A and B, I would just locate the midpoint. And then I would kind of observe my slope. So this is down 1 over 2, down 1 over 2. So our slope is negative 1/2. I take the negative reciprocal of that, so I flip it upside down, change it from negative to positive, and I have a slope of 2, and that would be the slope of our perpendicular bisector. And I can just start from my starting point and plot additional points by just going up 2 over 1, up 2 over 1, up 2 over 1. And I go backwards, down 2 and back, down 2 and back, and so on. I just connect them with a nice little line. Okay. And I have found a whole bunch of points on the perpendicular bisector. And remember, those points are all equidistant from A and B, meaning that any point on this line, if I'm at any point on this line, I'm the same distance from A as I am from B at any point on that line. Now here, we have a slightly more difficult problem because the midpoint isn't a whole number. That's going to sort of make things a little more difficult. And our slope is kind of a goofy fraction. So I'm going to show you a method that'll work every time for finding your perpendicular bisector. And it involves putting some tools together that we've used before. Okay. So first we need to find the midpoint. So I'm just going to put down here, find midpoint. Okay. So we have our formula for finding midpoint. So we just take our two x-coordinates, 2 and negative 1, and plus negative 1. I add them together, divide by 2. For our y-coordinates, I take the two y-coordinates, I add them together, divide by 2. 2 plus 0 over 2, which gives us a midpoint of, 2 plus negative 1 is 1 over 2, it's 1/2. And 2 plus 0 is 2 over 2 is 1. So the coordinates for our midpoint are 1/2, 1. And you can kind of see where it is. It's right about there. Okay. Next, we need to find the slope of the line. So let's go over here. I'll put find slope. So in order to do that, we had to find our delta y and our delta x. That was our change in y and our change in x. So say our change in y is, and we have to make sure we're traveling in the same direction for each, so just sort of arbitrarily I'm going to choose that we're going in this direction. So say our change in y went from 2 to 0, so end minus start, 0 minus 2 is negative 2, and for x, we ended it from negative 1 to 2, so end minus start, 2 minus negative 1 is 3, and slope was change in y over change in x, or negative 2/3, which we'd usually write just with the negative sign out front. So then we've got the slope of perpendicular line, and that's just the negative reciprocal of the original one, so we're just going to flip the slope upside down and change its sign. So it's currently negative, and we're going to make it positive. We flip it upside down, and we get 3/2. Okay. And now we're ready to find the equation of our perpendicular bisector, because we've got the slope of the line, and we have the midpoint, which the perpendicular bisector, it's a bisector because it cuts the segment in half. It goes through the midpoint. So the midpoint is on the line, and we're going to use that point-slope form that we talked about earlier to write the equation of this line. So that point-slope form, remember, was y equals, and it was m x minus h plus k, where m, let's write this over here, was the slope, and hk was the point that we were going through. So let's see. So So this is y equals, our slope was 3/2. 3/2 x minus our x-coordinate, which is 1/2, plus our y-coordinate, which is 1. And now we have the equation of our line. Right? Now we can use that equation to find some additional points on the line. Right, so let's take a look here. I'm going to, what am I going to do here? I'm going to, all right, choose, think about this. Well, all right, we're just going to make a table. We have x, y. Okay. So let's pick some points. I don't know, let's pick some points that are kind of out here a little ways. So we'll pick like 2 and, I don't know, 4. Okay, pick 2 and 4. Just a couple points. So let's see, we have, let's just kind of use some scratch paper over here. 3/2, 2 minus 1/2 plus 1. See, 2 minus 1/2 is 1.5. 3/2, 1.5 is 3/2 plus 1. That's 9/4 plus 1. So it's plus an additional 4/4 is, let's see, 13/4, which is like 3 and 1/4. Okay. So 13/4, oops, putting this on our table, 13/4, which is equal to 3 and 1/4. Now for 4, to kind of do this a little bit easier, I can just write my whole formula straight into the calculator. I could go using the ABC button. So I can go 3, ABC2, then in parentheses, I'm plugging in a 4, 4 minus 1, ABC2, close parentheses, plus 1. And this gives us 6 and 1/4, which 25/4. So 25/4 or 6 and 1/4. So I can go plot these 2 points. So 2, 3 and 1/4. So let's see. There's 2 and 1, 2, 3 and 1/4, which is probably somewhere around right there. And our other point was 4, 6 and 1/4. So let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And just a little bit more. And I'm going to connect those 2 points with a line. And this is like not a perfect operation here, but you know, just kind of eyeballing it, I do believe it does look like that cuts through the midpoint. Looks pretty good there, and it does also appear to be perpendicular. So I think those are good signs that we've done this correctly. So just to go back over the process here, so you understand what we've done. First thing we had to do, and this will work no matter what the numbers are, no matter how ugly or terrible they are, this will always work. So there's no special, you know, this isn't a special case. First, we had to find the midpoint of our segment, because we need that point. We know the perpendicular bisector goes through it. Then we need the slope of our segment, which we just find from the endpoint. So we find our change in y and our change in x. Remember, that's end minus start equals change. And we have to go the same direction each time. So then our slope is just change in y over change in x, right there. Then we had to find the slope of the perpendicular line, which all we had to do is find the negative reciprocal of this, which means you just take the fraction and we flip it upside down and change its sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. Also remember that, for example, the negative reciprocal of a number like 2, we think of 2 as 2 over 1. So its negative reciprocal is negative 1/2. Okay. Anyways, so once we know the slope of the perpendicular line, of the perpendicular bisector specifically, and we know a point that it goes through, we set up our point slope form right here, where m is the slope. So we've got m and x minus h and then plus k out here, and that's the point we're going through, which is going to be the midpoint, and that's going to be the slope that we found for the perpendicular line. Then we've got our equation, And we can find some additional points just by plugging them in. And remember, you can always just use the calculator to deal with any terrible fractions that you've got to deal with. Just punch it all in. It will spit out the answers for you, save you a lot of time. All right.